The gain that you get from sensory feedback seemed to be limited unless you were in a situation where you couldn't see. Admittedly, this varied from person to person, and for our situation, the gain of getting sensory feedback was much more limited than the gain that you would get from, keeping it cheaper.
And if I want to grab something, I just grab, and more times than not, I can visually see it, and I know how much pressure to apply. If I really need to grab onto something, it'll allow me to apply more pressure.
But I will say, from a prosthetic standpoint, they're always trying to get more sensory feedback and put it back in. The issue is that the sensors vastly exceed the ability to get that information back to the patient.
You really need to know, because if you're shaking someone's hand and that's got, especially the DEKA, who has a pretty decent amount of pinch pressure, as well as it can hold like a 40-pound bag. I could lift it up over my head. Like, you need to know how hard you're grabbing somebody.
About 7-8 years ago, DARPA decided to start up a prosthetics program, really in response to what was happening in Afghanistan and actually more in Iraq at that time. We were seeing many more amputations due to explosive devices than we typically had seen in the past. That combined with the fact that medical care in theater now is so advanced that if somebody gets injured with, say, multiple amputations, they're able to survive those wounds. And at that time also, if you looked at what was available in particularly upper extremity prosthetics, so prosthetic arms, most amputees still wear a hook, okay? So we've had the opportunity now to actually begin working with some of the patients. And, when you see somebody, the reaction of somebody that's never, that can't move their limbs or has lost a limb, and all of a sudden they have that ability again, I mean, it's a tremendously gratifying experience. That's what has kept most of us really passionate about this over the past 6 or 7 years. The whole vision of this program is brain-controlled prosthetics. When you think about moving your arm, the areas in your brain, there's an area of your brain called motor cortex. And that area of the brain is involved in actually moving muscles. And they're very specific areas of the motor cortex that are associated with the fingers, the hand, the wrist, the arm. So we can do a procedure known as fMRI, functional magnetic resonance imaging. What that does is when you think about moving your arm, think about bending your elbow. Think about opening and closing your hands. And you can look at what areas of the brain light up. We've developed a set of electrodes that are about the size of my small fingernail here, and they sit on the surface of the brain, and they have 100 electrodes, and those electrodes will measure that electrical activity. So I know where in the brain is involved, say, in controlling the hand. Okay, I know that location. We'll place those electrodes in that location. There's actually a pedestal which is attached to the skull, which then a connector goes to. And that connector then takes all those signals from those electrodes, puts them into basically a box, which then processes them and amplifies them and so forth, so that a computer can begin to look at them. So basically takes them from analog signals into digital, and you do process basically is called decoding, which is you try to figure out from what the patient's trying to do and what you want them to do, how to basically interpret those signals. I can move past training and actually allow you to do things. So we decoded from the brain, now we're going to encode, and there's another area of the brain called somatosensory cortex, in which is involved in sensory perception. What we will next do is actually stimulate those areas of the brain. We've done it on peripheral nerve. Next step is actually to do that in the cortex. So we do essentially the reverse of the process, so that we provide this sense of sensation back to the patient.
When they're doing all this nerve stuff now, I'm getting worried because I'm going, I never had a hand, and they always say like, oh, you probably have a nerve bundle at the end of your arm, but like, I don't know that. I mean, I'm sure I do, but to be able to, hook it up to the correct nerves, like, I don't know what I have or how it works. Or
we have worked with one congenital amputee, which is actually very interesting. When somebody's learning how to use a brain-controlled prosthetic, that they initially, will fumble around with it a little bit, but then the brain begins to, at some level, remap itself, and you learn how to more effectively control the arm. So it's really an amazing thing that we don't fully understand everything that happens, but it's very but the brain is very dynamic. So we started this program with the goal of helping soldiers that had lost limbs due to injuries. Many of those injuries occur because they have to go into very dangerous situations.
I'm an explosive ordnance disposal technician, or I was. I was overseas in Afghanistan on my second tour, and we received an IED call. I went out, we did everything right. Robot ended up going down, so I had to go down and manually take care of this thing, and it ended up being booby trapped. So when I was on top of it trying to uncover it, it was booby trapped to go off when I pulled the dirt off of it. So I was down there for maybe a minute. I dug about 2 inches into the ground, and then that's when it detonated.
So if I can take the robot arms, that we've made, the prosthetic arms, and I can put those on a mobile platform, so I can send the robot into a dangerous situation. There's lots of applications for robots to be able to do things that we don't want humans to have to do here. So we can help both ways. We can help with people kind of just going through the normal aging process and help them better adapt to that. We can also help prevent traumatic injuries from happening in the first place. And that's really our focus. Yeah, these things are very expensive right now because they're very specialized. They're very low volume.
If you wanted to just go out and buy the equivalent, it would start at about $350,000 and probably go up from there. That's not including the surgery. That's not including anything else. It's just the mechanical hardware. I would say that it would be even more expensive, but one thing you have to remember is that you can't buy this because it doesn't have FDA certification.
Prosthetics right now is a market which is essentially like a cottage industry. There's lots of little companies. They kind of make they each make their own thing. It's very customized. What we really think about now as prosthetics being part of robotics and the applications for robotics beginning to grow, I think we're on the same kinds of curves. That instead of what costs hundreds of thousands of dollars now will cost $10,000, maybe even less. So 10 years from now, I think we're going to have assistive robots in the house, and it's just going to be a common thing.
10 years?
10 years, sure. Maybe even less.